Tesla Bot Optimus, an ambitious product with the potential to be a financial game-changer for both Tesla and the entire market, is continuously touted by Elon Musk, who confidently claims it will be available for sale by the end of 2025 and speaks optimistically about mass-producing 5 robot legions. However, harsh reality seems likely to limit this goal. When will Tesla actually be able to begin mass production of the Tesla Bot? In today's episode, we will reveal 3 major reasons why Tesla is being forced to delay mass production, and the truth behind the scenes. And welcome to Techno Creators. Before we begin, please help us reach 5,000 subscribers. It will be a huge motivation for us to continue bringing you great tech episodes. The new hardware cannot produce for mass production. Although Tesla's greatest strength lies in hiring the smartest engineers in the world and motivating them to work at an incredible pace. If we go back to 2016, Tesla published a blog post stating that all of its electric vehicles were equipped with the necessary hardware to achieve full self-driving. This meant that owners of those Teslas could expect autonomous trips and eventually even send their cars out as robo-taxis to earn money when not in use. Later, Tesla quietly deleted that post, and now we can see why. Since then, Tesla has shipped millions of updated hardware, 3 computers to replace older hardware 2.5 systems, as they were not capable of achieving FSD. Now Musk says even those newer chips will also need to be replaced. Meanwhile, the newer hardware 4 computers have been experiencing some short-circuit issues, which have led to large-scale recalls in both the United States and China due to related symptoms such as malfunctioning rear-view cameras. Currently, the company is developing Hardware 5 for the Optimus robot. Although Tesla's 50,000 GPU training cluster at Giga, Texas, named Cortex, has enabled a breakthrough in the computing hardware equipped on Optimus, with major improvements in safety and comfort thanks to 4.2 times more data, higher resolution video input, a 2 times reduction in photon-to-control latency, and a redesigned controller, among other enhancements. Mass producing this hardware for Tesla Optimus is no easy task. Tesla still has many ambitious plans for its electric vehicles, especially the upcoming Model 2, which will require a significant amount of hardware dedicated to self-driving capabilities. The new hardware developed by Tesla specifically for Optimus is expected to be manufactured using a 7-nanometer process and will serve multiple functions, including autopilot and full self-driving. Additionally, Musk has stated that while Hardware 3 was revolutionary, Tesla has been working on a next-generation chip that will be approximately 3 times more powerful than Hardware 3. He later mentioned that this unreleased chip is expected to enter production in about 2 years. As a result, the mass production of the Optimus robot may be delayed until 2026, or even 2027. Globally, it's expected that at least 100,000 vehicles equipped with Hardware 3 and the FSD package will be on the roads, pushing Tesla's retrofit demand to over 500,000 cars. Musk was right when he said that replacing the computers in more than 500,000 Teslas would be painful. Not only would it put massive pressure on Tesla's service capabilities, but the cost could easily exceed $500 million. Before we move on to the next reason, make sure you've hit that subscribe button and turned on notifications by ringing that bell icon so you don't miss any future episodes. Production cost challenges. Recently, inflation in the United States has continued to rise, significantly impacting the overall economy, and particularly the high-tech manufacturing sector. One clear example of this impact is Tesla's struggle to realize its goal of bringing the humanoid Optimus robot to market at a price of just $20,000, a figure once considered ambitious yet achievable. Like many other manufacturing companies, Tesla is grappling with rising costs of raw materials, from rare metals used in actuators and sensors to the growing expenses of shipping components from suppliers around the world. Although the company has heavily invested in localizing production and automating its manufacturing lines, macroeconomic factors like inflation remain formidable obstacles. Tesla Optimus humanoid robot is expected to be a groundbreaking advancement in robotics and automation. Elon Musk has repeatedly stated that Tesla's goal is to produce Optimus at a cost of just $20,000, a price point that could make the robot widely accessible in everyday life, from manufacturing and logistics to personal care. However, in the current inflationary environment, that price target is becoming more difficult than ever to achieve. The costs of electronic components, AI processors, high-density batteries, and servo motors, all essential parts for operating a humanoid robot, have risen significantly. Additionally, labor costs in the U.S. are also climbing to keep up with the rising cost of living, further driving up domestic manufacturing expenses. Tesla has been expanding its manufacturing facilities in the U.S., such as Giga, Texas, and Giga, Nevada. These factories are not only producing electric vehicles, but are also expected to serve as future centers for the development and assembly of the Optimus robot. By establishing its entire production line in the U.S., Tesla can take advantage of tax incentives and support from the U.S. government for advanced technology companies. Although labor costs in the U.S. are significantly higher than in other countries, Tesla compensates for this by increasing the level of automation in production, using Tesla bots themselves to build an efficient Optimus production line with less reliance on manual labor. Furthermore, signals suggest that both the market and the tax policies set by the government appear to be recovering from previous tensions, making it likely that mass production of the Tesla bot could begin as early as the beginning of 2026. Short of autonomous. The final and most important reason that Optimus may be able to determine a specific timeline for mass production is that it seems to be at a standstill, or in other words, the robot's autonomy in its environment has not yet reached the expected level. Over the past few months, Tesla has focused on improving the robot's gait, making it more agile, powerful, and confident in its movement. The robot's movement speed suggests it may be able to reach 3 miles per hour. Elon Musk's latest event seemed to promise a bold future, unveiling Tesla's ambitious cybercab and the humanoid Optimus robot at the We Robot launch. At the event, we witnessed Optimus robots showcasing impressive interactions, engaging with guests by socializing, serving drinks, and even playing games like rock, paper, scissors. Just 2 years ago, these robots were like shy wallflowers, unable to take the stage without assistance. The evolution has been remarkable. On stage, Musk confidently declared that this would be Tesla's biggest product yet, sparking excitement not just for the robot itself, but across Tesla's entire portfolio. However, one of the Optimus robots candidly admitted on camera that it was being assisted by humans and was not yet fully autonomous. This revelation didn't come as a surprise to those familiar with the underlying concerns surrounding the event. There were echoes of previous controversies, especially when Musk had earlier highlighted the robot's progress by showcasing its ability to fold clothes. Observers quickly noticed the obvious presence of human hands in action, undermining claims of true autonomy in the robot's capabilities. Although in the latest update video, Tesla Optimus shows significantly improved mobility, no one yet knows exactly how autonomous the robot is in a factory environment or in daily life. It may have achieved over 50% work efficiency, but the rest remains a mystery.
In 10 years, probably 90% of miles driven will be autonomous.
Huh.
Wow.
That fast.
According to an internal report leaked at the end of 2024, the actual efficiency of Optimus on the factory line currently reaches only about 40 to 50% compared to a human worker, while the accuracy of its operations when tested is only around 70 to 75% in a standardized environment. When deployed in uncontrolled settings such as homes, offices, or construction sites, this efficiency drops below 30%. Although AI is advancing rapidly, for a humanoid robot like Optimus to achieve true autonomy, it needs not only flexible mobility, but also contextual understanding, natural language processing, dynamic environment management, and continuous learning from real-world data, capabilities that still face many limitations today. In summary, Optimus has tremendous potential, but achieving full autonomy in real-world environments remains a technical challenge that could take many more years to overcome. Much like Tesla's FSD system, the promise of 90% autonomy for humanoid robots may take a decade to materialize, if not longer. We've long known that Tesla has been using a customized FSD build to allow newly manufactured vehicles at Giga, Texas and Fremont to autonomously move from the production line to the delivery lot. Although we know they are using a customized build of what might be FSD unsupervised, Tesla has also confirmed that they have accumulated over 50,000 driverless miles in total from autonomous vehicles moving to delivery lots. This could be the first time a purely general-purpose AI solution for autonomy is being realized. Tesla and several executives continue to share more content about autonomy and the Tesla Optimus network. The same level of autonomy will be required for Tesla Optimus to participate in mass production, the ability to move independently to the staging area after completing the assembly and inspection process, all without intervention from remote operators. How was Tesla Optimus tested at the Giga, Nevada factory? Surprisingly, in an interview, a former Tesla engineer revealed that the Tesla Bot Optimus Gen 3 is performing tasks daily inside the Nevada factory, which is known for its large-scale 4680 cell battery production process used for the Cybertruck, Cybercab, and Tesla Bot. Optimus seems to be a good fit for this space, with a task in the factory that needs to be automated, but would take a long time to accomplish in the old way with robots and automation. This is especially true if Tesla has tasks that are always changing, where nothing ever stays stable. Humans spend time setting up equipment and programming everything to do something that may only last a few months before the equipment changes. Then, people need to go back and redo everything, creating a lot of technical overhead costs. You need to pay many engineers to do a lot of work. If you have a product like Optimus that is more flexible, you can assign a task, teach the task, and have employees teach the robot what they want it to do, as opposed to having an entire team of engineers program devices that allow you to set up and create tasks that can be automated. But this would be too much work for the amount of time the task would take, allowing you to use Optimus to automate those tasks and actually get a return on the time you would spend automating it.
Optimus is already performing tasks in our factory, and we expect to have Optimus production version 1 in limited production starting early next year.
In addition, Elon Musk has emphasized that the Tesla bot is performing tasks inside the factory. Although there has been no official statement regarding the specific tasks Optimus is carrying out, previous video footage suggests that Optimus may be performing tasks such as removing batteries from the production line and organizing them into trays. Sometimes the methods of operation need to be adjusted, but everything seems to be handled efficiently by Tesla's team.
But I think we'll literally build a legion, at least one legion of robots this year, and then probably 10 legions next year. And I don't know, it's kind of a cool unit, you know, units of legion. So probably 50,000-ish next year.
Elon Musk has unveiled an ambitious plan during Tesla's Q1 2025. Tesla aims to produce its first legion of humanoid robots by the end of this year. This isn't just a major technological breakthrough. With Musk targeting the production of 5,000 Tesla bots in 2025, these robots won't just serve in Tesla's factories, they could also assist with daily tasks at home, in hospitals, and even in emergency situations. These robots are not just machines. They're envisioned as companions, helping hands in every aspect of life, proving they're far more than simple automation. Tesla Bot is barely 4 years old, and its journey has been nothing short of extraordinary. What started as a person in a robot suit has now evolved into a fully functional machine, equipped with flexible movements and advanced algorithms that allow it to think, adapt, and assist. From supporting people in daily life to providing care for the elderly and disabled. Tesla Optimus is being recognized not just as a robot, but as a future caregiver, perhaps even the one helping take care of your better half in old age. We often compare Optimus to humans, a rather tough standard, considering that at the end of the day it's still just a machine. It hasn't yet surpassed the agility or responsiveness of a human being. But thanks to artificial intelligence, its ability to process and think has already reached levels beyond ours. while still remaining under our control. When we look at the big picture, Boston Dynamics has spent over 3 decades developing robots, yet their creations still mainly focus on running, jumping, and acrobatics. Similarly, some humanoid robots from China share the same traits. They can perform flips and run smoothly without stumbling. But what sets Tesla's robot apart is its ability to perceive the world more realistically, using a system of 8 sensor cameras without relying on radar, LiDAR, or any other scanning technology. Forget everything you know about Tesla's new plans for humanoid robots and its strategy to produce a low-cost car model. Now let's talk about a material that is lighter, easier to manufacture, and more affordable. This is a cost-effective solution that can create efficient solar panels. These photovoltaic panels, thin enough to power a home, are known as tandem perovskite solar panels. They offer higher efficiency than single silicon panels and can retain over 89% of their initial efficiency after 25 years. Could they be the key to a major shift in future housing? Perovskite, whether used in hybrid configurations or as fully functional solar cells, has finally become a reality thanks to several major breakthroughs at Oxford PV. And they're not the only research team bringing perovskite into the present. So how exactly did Oxford PV manage to achieve this? The breakthrough technology at Oxford PV has received praise from both users and experts. This new solar panel material could serve as a complementary addition to existing solar panels. The new flexible solar panel is a thin film photovoltaic device that absorbs sunlight and converts it into electricity using cadmium telluride, CdTe, as the absorber. It generates energy by absorbing photons from sunlight and then producing electrons that move from the N-type to the P-type side of the junction within the absorber layer. Unlike traditional silicon-based photovoltaic cells, these thin film cells are more stable, more flexible, more durable, and easier to install. It seems that Oxford PV is proving this technology has real potential, as the company has just shipped its first commercial batch, marking the first time these panels are being deployed anywhere in the world. This is a major milestone not just for perovskites, but for solar energy technology as a whole. In the case of perovskite for solar energy, different atoms are combined, but they interact in a unique way that makes them exceptionally effective as solar energy absorbers. Perovskite solar cells could be a true game changer compared to silicon, the material currently used in most photovoltaic PV systems. While silicon is durable, affordable, and relatively efficient, it is approaching its theoretical efficiency limit, about 33.7%, known as the Shockley-Queisser limit. By stacking silicon and perovskite cells in tandem configurations, this limit can be surpassed. Perovskite starts with an efficiency of around 20%, already higher than many standard silicon panels available today, and theoretically, it has the potential to go even further. CdTe solar panels are far more common in the United States than anywhere else in the world. But before diving into why that is, let's take a moment to understand what CdTe actually is. Tellurium is a semiconductor material similar to silicon. As the name suggests, CdTe is made from cadmium and tellurium, both of which are toxic on their own, but become safe when combined into CdTe. Cadmium is relatively easy to obtain, as it's a byproduct of zinc production. Tellurium, on the other hand, is rare, about as scarce as platinum, and is mainly found as a byproduct of copper mining, since it doesn't have many other widespread uses. What is the potential of next-gen solar panels for homes? Up to now, research has focused on developing synthetic perovskite materials with higher energy conversion efficiency, improving from an initial low of just 3% when the technology first emerged, to over 25% of solar energy being converted into usable power. This advancement enables devices to become smaller and more powerful. CdTe materials have a band gap of 1.5 electron volts, very close to the theoretical ideal for maximum solar cell efficiency. This value is slightly higher than silicon's 1.1 electron volts, allowing cadmium telluride to absorb high-energy photons more effectively and reduce energy loss in the form of heat, thereby enhancing performance under strong light conditions. Currently, commercial CdTe solar panels typically achieve an efficiency of around 18.6%, while optimized laboratory versions can reach up to 22%. Although this is still lower than the average efficiency of silicon panels, which ranges from 20 to 24%, CdTe holds significant potential for improvement, especially through copper doping, a technique that can push efficiency beyond 22%. One of CdTe's standout advantages is its ability to perform well in thin film form. While silicon panels lose significant efficiency, dropping to around 6%, when thinned to the same thickness as cadmium telluride maintains high performance. This makes it an ideal choice for applications that demand lightweight, flexible, and material-efficient solutions. However, perovskite solar cell technology is emerging as a strong contender thanks to its impressive lab-tested efficiency of up to 26.7%. Although it still faces challenges in durability and large-scale manufacturing, perovskite is considered the solid-state battery material of the solar energy sector, a breakthrough that is fast approaching. In December 2020, the technology set yet another world record, this time achieving a certified efficiency of 29.5%. In the future, perovskites may become even more efficient, as they can be tuned to target different parts of the solar spectrum. With these efficiency improvements, along with the relative abundance and low cost of their constituent materials, perovskite solar cells have the potential to provide a cost-competitive energy source, rivaling fossil fuels, for use in electric vehicles or residential power systems. How could Tesla's humanoid robot Optimus utilize solar panels? The future of humanoid robots isn't just about replicating human movement and intelligence. It's also about discovering sustainable ways to power these advanced machines. One of the most promising innovations in this field is the concept of solar panel skin, an idea that involves integrating solar cells into the outer layers of Tesla's robot structure. This would allow Optimus to passively harvest energy from sunlight, potentially extending operational time and reducing reliance on external charging sources. This system allows the robot to passively collect solar energy throughout the day, reducing its reliance on external charging systems and enabling it to conserve energy and be more autonomous in its power supply. When Elon Musk announced plans to send Tesla Optimus to Mars by 2026, we immediately recognized a technology with the potential to support Optimus in isolated operations on the Martian surface. By integrating solar cells into the robot's skin, Optimus could generate electricity directly from its environment while performing tasks, making it an ideal solution for extended missions, outdoor operations, and energy-intensive applications in remote or extraterrestrial settings. Imagine this. Tesla Bot is equipped with a 2.3 kWh battery pack, allowing it to operate for approximately 10 hours. If it were fitted with a solar skin capable of recharging at a rate of 2,000 watts every 6 hours, the system could continuously supplement its power supply. This passive energy harvesting capability would reduce the need for frequent external charging and significantly increase operational autonomy, especially in environments like Mars, where energy infrastructure is limited and sustainability is critical. As for now, over 60% of the lithium supply for U.S. automakers comes from abroad. If this reliance on foreign lithium continues, especially as federal tax credit regulations become more stringent, there's a real risk that 100% of electric vehicles could lose their tax credits simply due to lithium. Finding an alternative to lithium would be a smart move for forward-thinking manufacturers. So, what makes these batteries the next big leap in the industry? Let's dive in and find out. 1. Nanobolt lithium tungsten batteries. The Nanobolt lithium tungsten battery represents a groundbreaking advancement in lithium battery technology, offering significant improvements over traditional lithium-ion batteries. By incorporating tungsten and carbon nanotubes into the anode, this innovative battery provides exceptional advantages, including higher energy density, faster charge and discharge rates, and longer lifespan. Elon Musk has recognized the immense potential of this battery and sees it as an ideal fit for Tesla's electric vehicles, making the Nanobolt lithium tungsten battery a game-changer for the future of the electric vehicle industry. One of the standout features of the Nanobolt lithium tungsten battery is its superior energy density compared to traditional lithium-ion batteries. With an impressive 300 watt-hours per kilogram by weight, this battery offers 1.5 times the energy density of conventional lithium-ion batteries, which typically range from 200 to 250 watt-hours per kilogram. In terms of volume, the nanobolt battery achieves 500 watt-hours per liter, surpassing the volumetric energy density of typical lithium-ion batteries, which is around 400 watt-hours per liter, by 1.25 times. When compared to Tesla's 4680 battery, which has an energy density of about 272 watt-hours per kilogram, the nanobolt clearly offers a significantly higher energy density, demonstrating why the nanobolt technology is poised to replace Tesla's 4680 as the battery of choice for the company's vehicles. Higher energy density means the nanobolt battery can store more energy in a smaller, lighter package. This is a breakthrough for electric vehicles, as it directly translates into increased driving range and reduced vehicle weight. For example, if you were to replace the 54 kilowatt-hour battery in a Tesla Model 3 with a nanobolt battery, the driving range could increase by up to 20%, reaching 300 miles without adding any extra weight to the car. This gives the Model 3 a competitive edge in the market with a longer range while maintaining optimal vehicle performance. Moreover, the nanobolt lithium tungsten battery is equipped with solar charging technology, enabling the battery to harness energy from sunlight via photovoltaic materials. This reduces the need for frequent recharging, enhancing energy storage, and providing longer usage times. The integration of tungsten nanotubes increases the battery's electrical conductivity and mechanical strength, allowing ions to move more freely during charge and discharge cycles. As a result, the battery experiences faster charging and improved longevity, making it even more practical and efficient for electric vehicle use. As for pricing, while the cost of the tungsten battery may range from $500 to $800 per kilowatt hour during the initial phase, 2024 to 2026, due to its new technology and limited production scale, the growing demand for electric vehicles and high energy requirements will drive down production costs over time. By 2030 to 2036, the price of the tungsten battery is expected to decrease to around $300 to $500 per kilowatt hour as manufacturing processes are optimized and production scales up. This is quite high compared to the current battery cost that Tesla is using. While Tesla is working to reduce the cost of each vehicle component to increase competitiveness in the low-cost electric vehicle segment, a variety of options are proposed, even for the 4680 battery pack that Tesla is using. Reducing the cost of manufacturing the 4680 battery could lead to a reduction in the retail price of Tesla models. It is estimated that if battery production costs were reduced by 30%, from $100 per kilowatt hour to $70 per kilowatt hour, each vehicle using a 100 kilowatt hour battery could save about $3,000 just from reducing battery costs. With batteries accounting for 30 to 40% of the total cost of producing an electric vehicle, this reduction could reduce the total cost of production of a vehicle by up to 10%. This means that the cost of producing a Tesla Model 3 could be reduced from about $35,000 to about $30,000, equivalent to a savings of about $5,000 per vehicle. On the bright side, if Tesla can apply the cost reduction to its current battery lines, the higher energy density of tungsten could be reduced in the future. We can hope for a comfortable price of about $150 per kilowatt hour for this type of battery to have a different experience. 2. Zinc manganese oxide batteries. Unlike traditional batteries, the zinc manganese oxide (ZMO) battery represents a promising solution for the development of sustainable energy storage systems, utilizing zinc and manganese oxide, two abundant and easily recyclable materials. Zinc is non-toxic and widely available in nature, while manganese is known for its stability and durability. The ZMO battery consists of two electrodes, a zinc anode and a manganese oxide cathode. While these materials provide excellent stability, the energy density of ZMO batteries is lower than that of traditional lithium-ion batteries, ranging from 100 to 150 watt-hours per kilogram. This puts it at a disadvantage compared to lithium-ion batteries, which typically have energy densities in the range of 200 to 250 watt-hours per kilogram for electric vehicles. However, Given Tesla's focus on cost-saving strategies and emission reduction, it is highly likely that the company will explore new forms of zinc or zinc alloys to improve the performance of the anode. Additionally, optimizing the electrolyte to enhance the interaction between the electrodes could increase the competitiveness of ZMO batteries compared to traditional lithium-ion batteries. Equally important as battery performance is the cost of ZMO batteries. With a power density of 20 to 60 watts per kilogram and the availability of abundant, inexpensive raw materials, ZMO batteries offer a low cost ranging from $15 to $30 per kilowatt hour. The ZMO battery also offers impressive longevity. After 1 year at room temperature, it only loses 4 to 7% of its initial capacity, with a subsequent loss of about 2% each year. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this. Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.